So here we are again, another day and another video for learning AI. So today's topic is understanding neural networks. And again, this is ICANN AI Education. Before we begin, I guess it's best for us to know what exactly we are learning. And that is to describe what neural networks are, their architecture, and how they are used in AI. So we're gonna include discussions on activation functions and deep learning in general. Okay, so let's zoom in a little. All right, neural networks, what are they? So neural networks are a fundamental component of AI and machine learning. It is inspired by the structure and functioning of the human brain. So we know that neural and let's say neurons are all terms related to our brain. But how it works can actually be translated into how machines think, and that is through neural networks. Okay, so they are computational models composed of interconnected nodes called neurons, organized in layers. So again, they are models composed of connected nodes, which are called neurons, and they are organized in layers. Later on, I'm going to show an image on how exactly does that work. So neural networks are used for a wide range of AI tasks. It includes image recognition, natural language processing, and even playing games like Go and chess. So here's an overview of neural networks, architecture, activation function, and their role in AI, including deep learning. So let's talk first about neural network architecture. So a neural network should look like this. Um, is there a way for us to? Yeah, it should look like this. This is an architecture. It has an input layer here, so it means this is what you feed your model, your data. This is the hidden layer. So the hidden layers are basically processing everything, and then it would make an output layer which is only one because that is the outcome. So say you are predicting whether it is a cat, a dog, or a snake, for example. So you're gonna feed it data, and it's gonna try to analyze that, and in the end, it's gonna make one prediction, which is, let's say it's a cat. So that is for image recognition. So um, the input layer, like what I said earlier, receives the initial data or features. So each neuron in this layer represents a feature or an input value, like cat, dog, or a snake. So for image recognition, let's say, each neuron in the input layer could represent a pixel intensity. So a pixel is one dot of your screen, and it could have different color, different intensity, brightness, like white or black. So it could also represent that. So the hidden layer, which is the one in the middle, like here, they are between the input and the output layers, and the neural networks often have one or more hidden layers. So it could be one, two, three, and so on. Okay, so these layers perform complex transformations and feature extraction. So every time it passes through one layer, it is going through very, very complex transformation, and we are trying to extract the features of each. So the number of neurons in each hidden layer and their connectivity varies based on the network architecture. So this is just one example. And lastly, we have the output layer, which is this one. So the output layer produces the network's final prediction or the results, but it can have one or more neurons depending on the nature of the task. So for binary classification, you may have a neuron that outputs the probability of a positive class. In multiple classification, there are multiple neurons, each corresponding to a class. So again, if it's dog, cat, snake, then the prediction could be any of those. So that's how Similar to how we think, machine learning models think similarly. So the second one is what we call neuron and activation function. So each neuron in the neural network takes inputs and performs a weighted sum of these inputs, and then oops, it applies an activation function to produce an output. So every time, so this is what it looks like. So this is the input, and this is the hidden layer and the output layer. The activation function resides inside the hidden and outer layers, and they are performing it's a function. It's performing once it has gotten, let's say, an input, it will provide a calculation. It will provide an output. And so as you can see here, this particular let's say this particular node will have to be fed into one hidden layer node and to the other, and so on. But each of them will have their own activation function inside, and it's gonna make weighted sum calculation. And once it calculated that, it will provide an output, and so on. So this is how it kind of thinks. It uses math to solve problems. So it introduces non-linearity into the network, allowing the model to make complex relationships and patterns in the data. So we have a lot of activation functions, but here we are going to talk about probably just three, or maybe just one, which is the sigmoid. So the output values between 0 and 1, it often used in the output layer for binary classification. So if you just need to provide an output for 0, 1, then this is the right activation function. We have ReLU, which is rectified linear unit, and it outputs the input and positive values and 0 for negative values. And it's widely used in hidden layers due to its efficiency and effectiveness. So tan, or hyperbolic tangent, outputs values based between -1 and 1, but it's similar to sigmoid, but it's centered at 0. So now that's what we call neural and activation function. Now let's talk about deep learning in general. So it's a subfield of machine learning. So again, we have AI as the biggest circle. Inside AI, we have machine learning. And inside machine learning, we have what we call deep learning. So it is a subfield of machine learning, and it focuses on neural networks with multiple hidden layers. So these networks are referred to as deep neural networks, or DNNs. So the term deep indicates the presence of many layers. So it has many, many, many deep hidden layers, enabling the model to learn complex hierarchical representations of data. Deep learning has led to significant breakthroughs in AI. So particularly in tasks like image recognition and speech recognition, natural processing, and autonomous driving. So you know how Google Translate works, how ChatGPT works. Basically, it's a very complex model of deep learning. So CNN, which is convolutional neural networks, are used for image processing. Recurrent neural networks, RNNs, for sequences, and transformers for natural language processing. So all of them are deep learning models. Okay. Now, how we use them in AI, like what I said earlier, there's so many ways that it can be used. For example, it can be used for image classification and object detection. For example, you have 1,000 images and you need to classify each of them. Are they what? Are they humans? Are they animals? Are they buildings? So it could be a very tedious task, but if you're going to feed it with in a machine learning model, then it will automatically do that for you in a few seconds or minutes, and it can classify that based on the model. Speech recognition and synthesis. For this one, this is how a model can understand what you are saying in captions. So when you watch a YouTube video, even live, you notice that there are captions. It's not that somebody is typing that in real time, but it's a machine learning model who's recognizing those words and converting them into speech. Text. Natural language understanding and generation. For natural language understanding and recognition, this is understanding what you give it. So if you type a particular word, or not word, sentence, it understands exactly what you mean. And that's what happens when you feed it to, let's say, um, what? AI, ChatGPT, right? If you ask it to write me a poem or um, what is evolution and stuff like that, it will understand what you're saying and it will produce a very human like response. It could also be used for recommendation systems for, let's say, a business, what exactly we need or to predict, game playing, and so much more. So, machine learning models like neural networks, they excel at tasks that involve pattern recognition, feature extraction, and decision making based on complex high dimensional data. So let's summarize this. In summary, neural networks are foundational technology in AI and machine learning, and they consist of layers of interconnected neurons, activation functions for nonlinearity, and can be deep, like many layers, for learning complex patterns. So, deep learning in particular has revolutionized AI by enabling the development of highly accurate models for various real world applications, which we are enjoying now in so many ways. So, this is just a beginning, and I hope you learned a lot from this video on neural networks. For the next video, we're going to talk about data processing, and the lesson is entitled Data in AI Collection and Pre-Processing. So, I guess that's it for now. Thank you so much for your time and have a wonderful day. And bye bye.